look at your cheat sheet from today. Okay, the worksheet that we filled out in class and worked with a buddy on. Okay, this should help you. So I just want to re-explain it one more time. So first, you have the problem 2 to the power of 2 times 2 to the power of 4. So when you write it, you're looking at this base of 2 to the power of 2. So you write it as 2 times 2. Times, and there's my times, 2 to the power of 4. Well, that looks like 2 times 2 times 2 times 2. And we have the number of factors, we were counting them. 1, 2, 3, 4, 5, 6. There were 6 of them. So we could say this was 2 to the power of 6. Okay, and we did a few more examples down. And what I want you to notice is I want you to notice what happens with this factor. As you wrote it all out, you ended up counting up the factors that you had, and that became your exponent on your answer. Okay? So when you're looking at these problems, we had to come up with a rule, which you're supposed to write yourself tonight. So if you flip your paper over and you take a look at the product of powers, that's the first few problems that we did are using the product of powers rule. And these were 2 of the examples. What did you do to your exponents that gave you your answer? Well, you could write them all out and you could count them, or you could say that 2 to the power of 2 times 2 to the power of 4, you could really write as 2, and then the exponents, we added them, and we got our answer as 2 to the 6. Okay, and we can do the same thing with the m. You have m to the 5th times m to the 7th, and if you add those exponents, you get m to the 12th. Okay? Or you could write it all out. You can absolutely write it all out, or you can use this little rule. And the rule says, if the bases are the same, which ours were, our base here was 2 and our base here was 2, so our bases were the same, we get to add the exponents. And so 2 plus 4 gives me 6. And then we can try it again on the next one. Our bases are the same, they're both m's, so we can add our exponents. 5 plus 7 is 12. Okay? Now, you can remember, you don't have to add them. You can 100% write them out and count them up and get 3 to the power of 8. And either way will work. But we had another set of problems. We had the set of problems that had the parentheses. And this is actually for that second rule, power of powers. It means that you have an exponent to an exponent. So remember that this thing inside my parentheses, this is now considered my base. So I'm going to write it 2 times. 4 to the power of 3 times 4 to the power of 3. And now I can write it all out. I can say 4 to the power of 3 is 4 times 4 times 4. And this 4 to the power of 3 is 4 times 4 times 4. And I can multiply them all together. And I end up with 6 terms, which gives me 4 to the power of 6. Okay? But if you take a look at your exponents, power to a power, what did we do with the 3 and the 2 that got us a 6? Well, 3 times 2 makes 6. So let's see if that works for the next one. Our base is 7 to the power of 2. So I'm going to write it as 7 to the power of 2 3 times. And then I'm going to write it all out and show what it means. And now I have 6 terms, so I get 7 to the power of 6. Well, if I take a look at my exponents and if I add them, or if I add them, they make 5, so that doesn't work. But 2 times 6 makes, 2 times 3 makes 6. And so if you multiply those exponents, you get a 6. Okay, let's try it with our next one. This is our base, x to the 5th, 4 times. And you can write this. And then you can say x to the 5th is really x, 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 x. And then I have to do it again. And then I have to do it again for this guy. And then I have to do it again for this guy. And now how many x's do I have? I have 20 of them. So let's take a look. We'd have x to the power of 20, because that's how many factors I had. But if I took a look at my exponents, I have 5 times 4, which makes 20. Okay, so I'm not going to write this one out. I can. I totally can, and I will in a minute. But I want you to see if you can figure out the rule. So here's my power. So I have 2 to the 3rd to the power of 3. Well, if I multiply these exponents, I'm going to get 2 to the 9th. And then if I multiply these exponents, I'm going to get a to the 12th. And let's see if it works. I'm going to take my base, and my base is this whole thing, and I'm going to write it 3 times, because that's what my exponent is. 2 to the 3rd, a to the 4th. 2 to the 3rd, a to the 4th. That's twice. 2 to the 3rd, a to the 4th. That's 3 times. So I can keep writing them all out. 2 times 2 times 2. Here's another 2. 3 of them. And there's another 3 of them. Well, how many 2's do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9. 2 to the 9th. And now let's do our a's. I have 4 of them. 1, 2, 3, 4. And then I have another 4. 1, 2, 3, 4. And then I have another 4. 1, 2, 3, 4. So how many a's do I have? I really have 12 of them. So it's a to the 12th. Okay? So let's take a look at our power of powers. We're saying the bases don't have to be the same. It's not about the bases. It's about these exponents. Okay? These guys. And so when we have a power raised to a power, or an exponent raised to an exponent, we can say that we multiply. Multiply the exponents. Okay? But you have to remember that if there's multiple pieces, you have to multiply the exponents for each piece. Okay? Now let's do some homework. Let's try some of your problems. So I'm going to try number 5. Number 5 in your workbook says -6 to the -2 times -6 to the -3. So I'm going to go ahead and say, all right, well, my bases are the same, so I can do what to my exponents? I should be able to add them. So I'm going to write it as -6, and my exponents are -2 plus a -3. And so I have my -6, and when you add -2 plus -3, you get -5. So this should be my answer. And now I'm going to do a different problem. I'm going to do number 12. Number 12 says a bracket, and then in parentheses, to the -2, end bracket, to the -3.